course the BGM breaks because there we go. Hello everyone! It's Lina! Yeah, look a little different. Let's get the BGM a little. There we go. Something that might be a little better. Okay. Yeah, look a little different. New model. I have a temporary Chibi model. I'm already getting annoyed because I have the stream displaying on a little tiny monitor, and I swear it's like squished because the resolution is not where it's supposed to be. Oh, and I just realized I don't have my land mouse thing here. I should have fixed that. Hold on. So it's been a while and I've been fixing problems and I'm trying to fix lots of things that are broken here. Window, that doesn't work. Everything's broken. So, yeah, I have a new model. This is running on VTube Studio. And I'm gonna be using this for the time being until I have other this is not a my like, you know, I have a planned new model coming up. But this is what I'm gonna be using for now. And I hope you like it. It's really cute. It's really expressive. It's really nice. Well, a little slow though. I might wanna like change the smoothing settings. It's slow. But it's really nice. And yeah, I was a little late because I was trying to set up my Stream Deck to work with this thing. I've been hacking on my cursed, horrible, I want to rewrite it someday, control script that I've been using. Yeah, I do have all the toggles and all the things. Hopefully this works, as I just wrote this code. What could possibly go wrong? Testing in production. I hope it's also not lagging too much because this is also the first time I run VTube Studio and in my stream machine, and I don't know how the performance is gonna go, but yeah, we're gonna go with this for now. And hopefully it'll be good. Yeah, I swear that the screen here is one of those like horrible portable screens that has like the wrong resolution. I'm gonna have to do something about that. Oh yeah, that's definitely squished. Wonder if I can fix that without breaking everything. Let's see. Displays and monitor. Can I send like no, I can't. Yeah, it's one of those things like the the resolution of the panel doesn't actually match the like the aspect ratio of the thing because it's one of those weirdo tiny screens. I'm gonna have to figure something out to fix that. Ah. Yeah, I don't know how to add screen modes in Wayland. This is actually like an AMD system. I have no idea how to do that. I'll figure something out someday. But for now, I'm just gonna deal with it. So what I'm doing today, I'm now continuing to work on the Linux Pipewire video sharing solution. If you've seen, I'm sorry I've been away for so long. There's a lot of things have been happening. Life issues, health issues, random issues, all kinds of issues. But hopefully we're getting back on track now. Cyan is out. I don't know. She's like taking a little trip around the city by herself while I stream. So hopefully we're both good and we'll have more streams in the future. But yeah, for now I'm gonna get back to work. And sorry that I am so kind of derpy right now because it's been a while. And I lost it. And I was rushing to get the model working and all the settings and everything. So actually, yeah, you know what? Maybe a little wine is gonna help. Yeah. Just realized the camera calibration is like a little bit off. I think it's a little better now. Yeah, I think that's better. So yeah, I hope you like it. I hope everything is back to normal a little again. Sorry that I am kind of super derpy today. I'm trying to not... I'm trying to not mess up. Yes, we're gonna be working on the Pipewire video streaming solution so we can get things like VTube Studio working without having to use alpha. Sorry, I really am derpy today. Without having to use the green screen stuff, because that's what I'm using right now. If I'm just gonna show, I'm just gonna reveal my silly hacks. Yeah, this is chroma key. It's chroma key, but it's well adjusted, so it's not terrible. Why does it look blue on this monitor? Oh my god, the color calibration. This is terrible. Terrible. I really need to uncurse this setup. I think I just turned it off. Okay. I think I was like messing with the settings this entire stream while I try to figure out what's going on. Brightness, contrast. It's set to color temperature warm, and it's like extremely image ratio wide. I wonder what that is. It's definitely not 4/3. Okay, it's just wider 4/3. That's not useful. Why is it so blue? It's bothering me. It's bothering me. I'm so sorry. I'm like... Okay, there. Color temperature warm. User. Cool. Normal. Warm. Okay. It's like... Cool is like extremely blue. And like warm is like not warm enough, and it's like, I guess let's go to user. Low blue mode. Is that useful? Yeah, okay. So apparently if you turn low blue mode on, it's more tolerable. This is so cursed. How can I make a screen with the color temperature so ridiculously off? Okay. Give me more red. More red seems to like not work. I need to get a better screen. This is a little better now. Still terrible, but not as bad. Okay. Okay. You're not seeing what I'm seeing, but yeah, I was just adjusting the color temperature of my monitor because it's so bad. Okay. Oh, everything is cursed. You have no idea how, like, I have this, you might have seen the previous thing I was working on, the Neko deck thing, which is still planned. Since that's not ready yet, I've been working on this super cursed script that I've been hacking on forever. Oh no, God, now my eye color is wrong. Whatever. And yeah, it's a giant Python script that is getting more cursed by the minute. And now that I had to add VTube Studio integration, it's even worse. It's so bad. Okay. Ooh, I really am like super derpy today. Okay. Is the new model going to be 3D? There is going to be 3D and probably 2D also. So we'll see how that goes. Why is this stream so scuffed? Oh, I just realized this partially is the angle of the screen. Oh yeah, it's one of those screens where the angle of the screen just completely messes up the colors. That's a little better now. I think that's to get more brightness. It's always at 100%. Whatever. Anyway, yeah, so hopefully we're gonna be working on the pipe wire video sharing thing. So what I wanted to do is I think I already forgot what we did last time. I'm like so completely lost all my context. My plan is to break out the pipe wire sort of wrapper, the boilerplate code that we have to write to make this whole thing work at all, and we're going to be breaking it out into a library that other apps can use, because I've been talking to some people that write apps that might want to use this, like Spout2 on Linux. And I think one of the first things I want to try is making Godot work with it, because there are several people using Godot who want to support Spout2 like functionality on Linux. So for that, because Godot is basically it's basically using Vulkan, the current version of Godot. That means we need to have Vulkan support, and that is a good reason to write a Vulkan version of this whole thing, because oh my god, is the audio glitching? I hope it's not glitching. I think my what's going on? Real-time audio, how does this work? Why is oh my gosh, is real-time like not working? I feel like no, I do have some. Oh, but I think some real-time stuff is not working. Because I'm hearing some audio dropouts on my end. Oh, I don't have real-time setup installed. That's probably part of why. Can I like CHRT some things here? The thread that is using CPU is 498402. And yeah, that doesn't have priority. Okay, that's probably why. Everything is scuffed! Pit 498402. Yeah, it's definitely pretty scuffed right now. Set this to shed RR and priority -5 or something? No. How does this work? I think that worked. Priority 5 seems to have done something. Priority 10 seems to be doing better. Okay, I think that helped. I think that helped. Oh, everything is so scuffed. Okay, I think I improved a little bit. But I'm MPV. MPV should also be getting real-time privileges. Where's that? Because that's Python. That's the... task. How do we get home? Probably one of these. PWBGM player, since I'm alright. Give real time to that. Give whatever this module RTS, pipewire stuff. Hopefully that helped a little bit. Let's also do this data loop thing, whatever that is. Okay, I don't know. Here, I'm just like unscuffing things in real time. I think that's possibly a little bit better now. Yeah, I think it's less scuffed now. Wait, why is Piper itself not... Oh, Piper is only nice, not RT. Okay, everything is scuffed. 1821. I think those weren't supposed to be real time. Well, I don't care. Everything is scuffed. Scuffs. Okay, hopefully it's a little better now. I actually streamed from here before and it wasn't this bad, but I guess it's because now that I'm running VTube Studio, there's a bit more CPU load and there's a little more bork. Okay. Alright. So, hopefully this will... Hopefully this will work. And I have some really... I don't know what my brain is doing today, seriously. Like, too many things in my head. The stream was late. I was trying to get the Stream Deck stuff working so I could change the settings. And then all this stuff. I need to take a breath. This is mostly, at least it's mostly working. What Linux distro? This is Fedora, both on my machine that I'm going to be working on and on my stream machine. Both x86 because for the wine stuff I really need to develop on x86. Actually, what I'm doing today, if I'm going to be working on the oh, audio is glitching again. Why is VTube Studio like dropping frames? Is OBS dropping frames? Who's dropping frames? Oh, I think it's because... Oh, it's probably because of the OBS... Yeah, OBS doesn't like the window being too big. Like, I have a 4K monitor, and I think OBS just doesn't like it when... Yeah, when the window's too big. I need to figure out how to improve that. Like, I think there is... There's gotta be a way to make it not use the GPU so much. Just because the window is full screen. Yeah, if I full screen the window, I can see it, like, dropping frames on the GPU. Oh yeah, I can see it, yeah. When the window is full screen, it gets rendering lag. I make it small. It still doesn't hit 60 FPS though, which is kind of annoying. How can it be so slow? Come on, I know this is integrated graphics, but it can't be that slow. There's gotta be something silly here. Everything is scuffed. If I close the projector, it gets a little bit better. Come on, there has to be a way of making this not so scuffed. Is there like a GPU priority thing that you can use on like Radeon? Everything is scuffed. Hold on. Can I change the GPU performance on like? Can I like force the P state or something like that? Come on, now I'm running VTube Studio, but there's no way that this OBS stuff cannot hit 60 FPS. Power DPM state. Okay, that sounds reasonable. Card 1. Device. Power DPM state. Is that the performance? power, DPM force performance level. There's gotta be okay. If I set this to high, is it gonna? Nope, still not. Come on, there is no way this cannot sustain 60 FPS. What? Is it because of all the screen capture stuff that's going on? I'm gonna have to, like, profile this someday because this is not making sense. Is there like a performance top utility or something in deep GPU top? First. Come on, how can this be so slow? Like, there is no way. Like, do I have to upgrade my GPU just to make this not terrible? I think all the audio just broke because my real-time stuff was still breaking again. This is what happens when I compile stuff on my stream machine. Where am I? Okay, back to that. Yeah, I really need to figure out this real-time stuff. I'm just gonna change all the Carla tasks to real time. Okay. And TTP top. Graphics spike 100%. Okay, that doesn't sound good. Texture pipe. Why is everything 100%? Oh, come on. How can I possibly be maxing out this GPU with one VTube Studio model and OBS? Claims OBS is using 70% and VTube Studio is using 30%. This is terrible. It also claims to be using all VRAM, but I think that's just nonsense because it's going through GTT for most of it. Come on, you know this is a Radeon 610M, but how can it be this bad? Whatever. Okay, let's deal with it. So today is gonna be the scuffed, slightly frame droppy experience. Alright. Let's switch to my coding machine and see what we can work on today. And hopefully hopefully I'm good here. I think so. Alright. So at least my model moving shenanigans works. Come on, I cannot be stuck at 50 FPS. That's so silly. Do I have like some weird scaling thing going on? Yeah, all these have like scale filtering off. Oh, is my OBS set to like my profile set to something weird? Or like the video format? No, it's all in V12. I was hoping to use 2 models here in the future, but it looks like that's going to be a problem. Now, there has to be something really silly here. Like, if I turn myself off... Oh, now it's 60 FPS. Wait, hold on. It just fixed itself. Now it's suddenly extremely fast. 10 to render frame 2.7 milliseconds. Wait, I just went to settings. Came back, and now it's fast? Okay, I think I've seen this before. There is some kind of OBS thing where like... Oh, is it this? Oh, it's the solo scene. Oh, it's when you have multiple scenes open, okay. So it's the studio mode thing. Yeah, if I said... Okay, this is really funny. If I'm currently in this, like, desktop preview, right? It says render time 2.4 milliseconds, 60 FPS. That's what I expect. My preview is now a black scene. If I set the preview to the same scene that I'm currently running, render time jumps to 18 milliseconds. That makes no sense. It's the same scene. How could it possibly be... How can it possibly be, like, that much slower just showing a preview? Okay, I'm gonna have to, like, profile this at some point in the future because this makes no sense. So hold on, is it the background? What source is it? If I turn off the background? No. Ah, it's the capture. Ah, it's... Oh, I think I know what's going on. Oh, I think I know what's going on. Like, well, if I preview my capture source, it's fine. Hold on. I'm gonna add a scene. Move it all the way to the bottom. Aha! No, it's not. Okay, that's weird. Oh! It's the nameplate. It's whatever. It's like... I think there's some kind of VSync thing going on here. Because, like, render time is like... 3 milliseconds? And then if I enable too many things... it falls off a cliff. Oh, is it just because the GPU is like... Okay, I think it's just that when the GPU gets maxed out, everything just kind of lags. Fascinating. Fascinating. I'll have to figure out what's going on here later. Anyway, this is so silly. Okay, sorry about that. Well, at least I know it can do 60 FPS now, as long as I'm not previewing the next scene, like in studio mode. I should have just like shown you my stream machine while I was doing this. It's so funny. Because I can't actually do that. But yeah. Anyway, sorry about that little distraction there. At least now I know it can do 60 mostly. Alright, anyway. What am I even doing today? I am so, like... So... I don't know what I'm doing anymore. Anyway. Alright, give me a second. I'm gonna get some water and we'll get to coding. Right back! And I'm back. Okay, so what we've learned today is that I need to change my horrible script so that it switches the previous scene to black after all scene transitions. So that it saves GPU time. I'm really bothered by that now. Okay. Let's do exactly what. So Vulcan, where is my code? I don't even remember where my code is. Where did I put this? Is it Proton or no? I don't remember what anything is. Spout? No. Where did I put all this? Actually, I don't show anything weird while I figure this out. I don't think there's anything here though, because this machine doesn't really have anything. But it's under dev. Okay, that's where it is. So, yes, my brain not working today. I don't know. I think I might need some coffee. Let me drink some coffee. I think that's gonna help. Brain not working. So, what I want to work on today first is take the test code that I wrote in the previous stream that was doing the pipewire sending from Spout2. Take all the pipewire stuff, break it out into a library, and so there's gonna be a bit of design going on here. So this is basically gonna be a library that serves the purpose of the Spout2 sender side on Linux. I'm not going to write a receiver side because that's kind of mostly a completely separate thing. Because this will go through sender pipewire. So OBS already has a receiver that I'm going to use as a base for the plugin I'm going to write. So we only really need the sender. And I don't even remember what the PW sender is. Is this what I was doing? This is something else, right? Isn't it? This is what? Is this what I don't remember. Something like that. Yeah, I think this is the test that I wrote. So, I'm going to be breaking this out into a library, and the idea is that there's going to be a base implementation of the pipewire stuff. And so pipewire just sends buffers, right? It sends DMA buffers. So you can get those out from different graphics APIs. So the library will then have sort of configurable front ends for it, so you can integrate it into a Vulkan app or an OpenGL app or whatever else. And I'm actually interested in Vulkan first, even though the test I did previously was OpenGL, which is easier, because the thing is the textures that I get from Proton using DXVK are actually Vulkan textures. They work in GL sort of by accident, but it's not guaranteed. So the correct thing to do is to use Vulkan. And so, since we need Vulkan for Godot anyway, that means I get to learn Vulkan today. So we'll see how that works. But we're gonna try. Yeah. Okay. So let's get started with all this. Basically, I'm going to create a new... it's going to be a library, but I guess... do I want to start working with it as a standalone app? I guess I can just have both in the same Mason project. So, what do we call this? We need a name for this project. We need a name for this project because it's not Spout2. There's Spout2 for Windows. What is the macOS version? Siphon. So we have Siphon, we have Spout. I need a word that's like that for Linux. need a word that's like spout. Siphon, spout. Like faucet? No, it's too... It's not a great word. Pump check? Let me think. Sprinkler. It's like something that is like it's gonna be sender. It's mostly really the sender side, so not really the receiver side. So something that sends. Nozzle. Yeah, nozzle. Nozzle might work. So the question is that taken? That is apparently a thing. External tap devices, of course, that has it's a tap. So not nozzle, funnel, funnel. I bet that's taken. Oh, that looks like it's not taken. Huh. Funnel. Funnel. Yeah, I think we can do with that. All right. I think we can go with that. So, funnel. I think the first thing we need is a bit of an API for this because this is a whole mess here. So let's see if we can build a bit of an API for this. So this is mostly what I have here is mostly a test from before. So, let's get open funnel.h here. Can we use this these days? I think we can just use that these days and not require on the city include guard. What just crashed? I have no idea what just crashed. Whatever. So about the API, there's going to be a, the concept is that you can, of course, have multiple instances of the API. No global state, because global state bad. The plan is to make this, the library is going to be written in C, because it's mostly wrappers around C APIs. So, like, I wouldn't mind writing it in Rust, but I think I'm going to be fighting the bindings and abstractions more than it's worth for that. If it were a lot of logic, it would make more sense. But mostly the only data structures that I use here are like a list of modifiers and things like that. So I figure it doesn't really, it's not a borderline, but I think it's fine to write in C. Makes it a little bit more universal anyway. And but I want to write design the API so that it is easily bindable to other languages. So no public structs. All based on like getter and setter and configuration functions. Spout2 is a library used on Windows to send video between different apps. And there's a similar thing called Siphon on macOS. Linux has Pipewire, which can do that, but there's no easy to use wrapper around Pipewire. So basically, I'm going to build Spout2-like functionality on top of the existing Pipewire stuff. This is going to be using Pipewire, yes. So what this is, which is what I was working on last time, is basically a lot of boilerplate using the Pipewire and DBM and TL and Vulkan APIs so that you can easily send video from one app to another. So we need an API for this. Funnel CTX, so we have a context. So this returns a context. I think we can kind of go with the convention that all functions return an int and negative error code kind of stuff. So this will allocate the CTX funnel init. Let's see. So then we need a concept of a stream, because you can have multiple streams within one pipewire setup. So let's do a funnel shutdown. So we can create a stream, and then let's see, anything about this API. Actually, stream create and stream destroy. We also have to think about the like, let me say this, the threading implications of all this. So I think the idea is that depending on the API you use, you either call everything from a single thread or just push frames. I need to think about this a little. I actually had all this thought out after the previous stream, and then stuff happened, and I didn't work on this for like 2 months, and now like everything has left my brain. Well, we'll try some stuff and then adjust it later as we go. So one of the things that this has to deal with is there should be a push API and a pull API so that the receiver can ask for frames or you push frames. We're going to start with the push API, which is what most things use anyway. So for Spout2, I actually want to use pull eventually. So let's see. So stream create, it's a stream and the name. Start. Or you used to have a stop also. And then we need a way to actually integrate this into graphics APIs. So the easiest thing we want is the let's start with a push API. So I'm gonna have to like add glue between these things. But for OpenGL, in particular for let me think about this. For EGL, the easiest way to integrate this is to have like a texture that you bind and write to. And I think normally what people do is they will just like send a copy of the current FVO or render to a different FVO or something like that. So let me think what's the easiest way to integrate this. Because I want it to be flexible but not too difficult to use. For EGL, let's see. The way this works is that you build a bunch of buffers and then you... Let me look at the main code. Split this. Do this again. I think I can change this to the right side. Make it a little bit easier. So the way this worked when I was doing it like this is the actual data stuff, basically you get a callback on process, and then you queue a buffer. And on callback mode, you're supposed to call this from the process callback. On if you're pushing, then you pretty much just do it. I think you can just do this from any. I think you can just do this from any thread. So in that case, I think we can pretty much just. I think you just get an EGL image. So we'll do something like funnel EGL. Well, first we need to set up a like an API mode, and I guess that can be per stream because why not? I guess there's no real reason to not have the API mode be per stream. If you really want to mix like GL and Vulkan for some reason. I should also do a... What's my format here? Control TF. So the image is an EGL. I think these are just are these just integers? Or is it opaque? Why is this Android? Actually, API shouldn't be set up here because we want that to we're gonna have to have more initialization settings anyway, so probably need a funnel stream init EGL, and then we get like an EGL display or something like that. Because we need to get the render node from the device. This is EGL device X comes from the query on the display. Yeah, we need an EGL display. I might want to move these to different header files eventually, but for now it can just be here. So for GBM, we would use a GBM device. Which I guess can just be an FD in this case. The API there. And then from Vulkan, we'll figure something else out. so once we have an EGL display, we can query the DMA buff modifiers on that and figure out the supported modifiers, so we can do all this stuff. For EGM, for GBM, we're gonna have to do like a modifier list. Yeah, so to do this properly, we're gonna have to like a list of supported formats and modifiers. For GBM, so we can do that later, but we need at least should have some API for this. I guess we can just pass it here in GBM. So each format is a DRM format, which is the 32-bit integer, and a list of modifiers. So basically, just an array of those, and yeah. So for GBM, we do that, and the thing is, this can be used internally, right? So we could do a thing where yeah, we can do a thing where one of these APIs builds on the other, right? Which makes sense. What code editor is this? This is Kate. Yeah, so I'm gonna want stdint in here. Isn't that a stdient? I think it is. Anyway. So EGL image is, yeah, it's just a an arbitrary thing, so we take it like that. And in this case, we would just dequeue an EGL image and draw into it, which is easy enough. So we enqueue image. And then for GBM, it would basically be the same thing minus except the GBM BO. Actually, image is redundant here, so we just call GBM DQ and GBM NQ, and this will take a struct GBM BO. I think. And at some point, we're also going to have to deal with the explicit sync stuff, which is another mess. How did I do the offsets here? I get DBO, get offset, and stride. Okay, so the FTs are all the same, and then you get offset and stride. That makes sense. And then for Vulkan, it would be some kind of Vulkan image thing, which we don't have yet. So let's see if we can make this work with EGL for now, since we have the code for that anyway, and then plug in Vulkan. Oh, size C is standard def. Okay. There we go. So the only thing with EGL is we probably want to control the formats at least. We probably don't need to do any modifier stuff for EGL because that's the kind of the whole point of this is that it would deal with that on its own and negotiate everything. But at least we want a list of formats. But it's kind of opaque which format we want to use. So I think we could probably just simplify this for the purposes of this API. So the way this works with formats is query DMA buff modifiers ext format supported formats. This is coming from query DMA modifiers ext. Where's the formats? Okay, these are just the ones we have internal. Yeah, that's the whole like attribute thing, right? It's not really what we want. Oh, give me a sec. So, ETL formats. Yeah, I think it doesn't really have this concept. I think EGL just uses the whole attribute mess. I don't think EGL really has a... Yeah, it's basically RGB or RGBA, right? Does DBMBO have a format concept? Yes, I think it does. Yeah, it does have a good format. So the Debian API can just get the formats for you. For EGL, I guess we could just have like a structure for configuring the EGL formats or something like that. Maybe. It should be const while we're here. And Piper is using is it queuing PW buffers. Maybe you should just have a wrapper for that. I think it makes more sense to have a wrapper for that. So that it can keep track of what it is, yeah. Yeah, we just have a funnel buffer. Stream and queue, DQ and EQ. And then we can just have get EGL image. And so for EGL, we probably just want to have a list of formats, I guess. Or maybe just have like flags. Yeah, probably just flags because like all the RGB and BGR, like, these are all simple ones. So, so for is there a way for an ETL image to get like if it has an alpha channel or something like that? I think there is probably some way of doing that. Not Android. Yeah, so ETL create images uses attributes and stuff. There's probably an ETL get attribute or something like that, right? Or maybe not. There's a gray surface. That's not what I want though. I think we probably need like a query here or something like that. Is there really no way of doing this? There has to be a way of doing this. Or maybe not. Let's see, for GBM, sorry, for ETL, how do I want to specify the formats? Probably, like at least basic RGBA bit type of stuff. Yeah, I guess it's just make an enum of basic formats. Also, why is this formatting like with wait, is that with 4 and then with 4? Why is it using 2 spaces here? I think it's because I think it's C++ or something like that. Probably thinks it's C++. No, it's not doing that. Why is it not doing that? Oh, it's CPP for both. Okay, never mind. Ah, okay, that's what it was. I guess CPP for both C and CPP. Okay. So EGL format. Do I want to pass the list or do I just want to like have an add format type of deal? Because I don't like using structs anyway. It's a little bit less practical. So maybe I want to just change this. Just have GBMFD and then like a format list. Yeah, that's probably a little easier. I don't really like structs. It gets a little bit just got a format, I guess. Maybe enable format. Yeah, I think this works, and then you just enable all the formats you want to enable, and then as far as priority order, they probably should be just. I guess we can just use the user supplied order. So. Probably should write some documentation for this anyway. How do you do SD documentation? What's the way the thing people use for C Doxygen or something? I guess I just use regular comments for now. I forgot how to generate C documentation APIs. Yeah, just param. Okay, fine. Because I might as well sort this like that. And we're going to Can I just literally use like Rust conventions for this? I'm also thinking of like how a Rust binding for this would work, because the issue with these like sub object type of deals is always like, how do you keep the parent context alive? I think the way I would do it in Rust is just keep references to the primary context inside the like stream wrappers and stuff like that. Yeah, I think I would just do it like that. Basically just an RC in Rust. Probably doesn't need to be arc. It might, we'll see. But at least I'm gonna just have that in here. So, How does EDL display work? That one is to do. Actually, no, we said we were going to enable format. We don't use this anymore, so I'll drop this. Sorry. Okay. Stream. And then this is just the format there. I think we need a separate function to register the stream, because we create a stream, we initialize it, enable the formats, and then register it. Do people use, like... Yeah, I guess people do use complete sentences. Okay, so start running the stream, and stop running the stream. you probably want like a set buffer skull or something like that. Because there's the thing, yeah. Speed range int. Default min max, yeah. We probably want that. We want like a stream set buffers. What's the right... I guess for buffer counts, it really doesn't matter what type you use for this, but if you're using, I think you have like API integration here again. Int, maybe? I guess I will just use int. I like it. Yeah, it works for me. I like it. It's pretty, you know, straightforward and easy to use. Okay, register the stream. Start, stop, destroy. And oh yeah, we need to set the resolution, of course. This is the initial configuration. And then so we have this build format stuff, and I guess we probably have a get dimensions here too. Get size, because the one of the issues that happens with this kind of video sharing is that when you change the dimensions, you still have buffers going around with the old size, so it's not synchronous. So we probably should have a setting, I think here, so we can grab that. What is a good type for width and height? Probably UN32T. And that can be void. So you want to set buffers, enable format. Yeah, make node, then create the stream, and as the stream connect, and then the on-parent changes when we grab the video format. And it has to set the buffer parameters. Update params. Yeah, so we call build formats again to rebuild the format config. Num formats, build formats. Yeah, so build formats gets called with the with false first and then with true. Fixate. So fixate, it does this with a single modifier and all that. And this is because we're doing a weird thing with the multiple formats in a single setting, but we probably shouldn't use that. We should be using separate formats for each one. I just use UN32 for this, because negative and stuff like that doesn't make any sense. Or does it? No, actually, let's leave it as int in case we ever need to redefine like a -1 or something for any reason. Set buffers, and then okay, so let's go back to documenting things here. So we need a function to return a buffer that we haven't done anything with. And then let's see. I'm not documenting the errors yet. Okay, that works. Label format, generally set buffers. We probably want some other configuration stuff here. Stuff that goes into pipewire. We're gonna have to add stuff for explicit sync, but that can come a little bit later. And then also the stuff for the driver versus non-driver. The driver stuff, yeah, we're gonna have to figure that one out a little bit later. So I think we can start with this to see if it makes sense. So we have the enable timeout stuff. This was because we're not running on pull mode because OBS didn't support the pull mode properly. Remove buffer, create modifiers 2 and buffer. Okay. When agreeing a lip funnel of lane for Godot at some point. Yes. So this will be integrated into Godot at some point. Okay, cool. I think this is a good start for an API that will work. We probably want more control over the streaming stuff. So pipewire, DMA, buff. There is some stuff here that needs to happen. Yes, for explicit sync, Yeah, but we'll deal with this later. But I think I can just handle it by like having an enable call for enabling explicit sync, and then, all the extra stuff you need to make that happen. And I can, for EG, I can probably make it just work. I should look at what OBS does for explicit sync, but yeah, we're gonna deal with that later. That only really matters for NVIDIA GPUs right now. So the other thing is, we probably should set some metadata for like FPS and things like that. That is optional, but there is frame rate thing going on. Let's just do a little fraction thing here for frame rates. SPA fraction is yes, do that. So that is the same convention as Pipewire. Is this how you see it? I don't even remember this how you do see. I think it is. Okay. Okay, I think this makes sense. Another thing that we're gonna have to do eventually is set up for pipewire integration with like with like passing a file descriptor and stuff like that. And then we'll have to figure out the media class and all that stuff. But for now, let's just go with this. And instead of stream register, I think at this point we probably want to just no, I guess we can just use register, yeah, because then it adds the listener and stuff. Okay, getting somewhere. So now basically I have to just move this entire mess of C code here into a library. And I probably want to split up the GBM, GL, and Vulkan stuff later into several files. So, actually, I probably want to do it now. So that you don't necessarily have to have all the APIs built to use the header file. Where is this thing? This is GBM.h. I think, does... I forgot how include works in C. Is it always related to the current header file? If you use quotes? I think that... Yeah, I think quotes are supposed to use relative, right? So in that case, we can just do we can just do that. And put this in here. Okay, something like that. Info format. Put these in include and create a source directory. So I guess GBM is just going to be implicit anyway, because everything uses GBM under the hood. So just have EGA and Vulkan as separate files. Mason build. Fun little test. Call that test EGL. How do I do libraries in Mason? Just like that. EGL, EGL. Okay, this might actually work. Hello, everyone. Okay, so we have some form of let's close this stuff. Food. Open all those. Close. 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 And then we call this test EGL. Okay. Let's see. Can I mason this and get somewhere? That actually worked, except it did not. Okay. Okay, that makes sense. EGL. And link with. Oh, okay, you need to do that. Yeah, sure. And now we need to get the pipe wire dependency, which is already set up, but need to move that over to the other file. So if I just take most of this is going to go in funnel.c. So we can drop all the GL nonsense from this one. And they're gonna need like an internal file for the stuff, so throw that at the top. Probably don't need math. And how do I get this to use the right include? Ah, you can just pass it like that, okay. Oh, these should already get it because they have a dependency there, so. Okay, cool. So now this funnel thing. So no globals, definitely no globals. What goes in our structures here? So our funnel, stream buffer, get all this stuff. I think I can actually just include the GBM stuff in here because yeah, the EGL image is just a void. And that's an EGL. I think we can just have these as compile dependencies. How do we do that in Mason? Because I probably want all the EGL stuff to be like build dependencies, but not runtime dependencies unless you use the libraries. Which only matters for the shared library. I'm not sure that even is required. It might just automatically do the right thing. I'm not sure. I don't know how this is supposed to work. And I guess that doesn't really need GL. It only needs EGL because we only deal with EGL image. And So let's delete all this initialize EGL stuff. All these globals. Don't need this GL nonsense. Definitely no X11 window. Okay, so this struct data is where most of the fun stuff is going to be. So in internal, funnel CTX, funnel stream, funnel buffer. So the main loop goes in here. The core goes in here. Stream stuff would go in here. So stream listener stream. Context goes in text, and I guess the timer also goes in here probably. Okay. So, no main on this one. Pipewire.h. Okay. I think I'm just gonna copy this to a new file, so I'm gonna start deleting things so this can actually build. So in test DGL include funnel.h and funnel egl.h. And we're gonna need all this stuff. Most of this. Don't need 4 CCs. No SPA. No pipewire. Probably need some of those. Don't need GVM. And then most of this goes away. So let's actually try writing the client side first. So the client side here, I've initialized EGL, display EGL context. So we don't need a GVM dev on this. Don't need the render node because that is going to be queried by the device. Don't need the GBM stuff. And then the formats are not going to be dealt with here, so we can just drop all of this. Just get an EGL config out of this. Don't need the render node. Don't need this. Don't need that. Static, initialize EGL. Okay. GL setup scene. This is all fine. This is all the general GL stuff. Draw scene. Yep, that's all cool. Draw triangle. Excel window. Yep, this is all fine. And then, so no GBM dev. Do init. Do render. And then here's where we actually use the API. So for the API, what we basically want to do is just have a main loop. Okay, doing it. And then we just call our API here. So, cert Funnel init. And then for the main loop, this gets called on the process call. We actually we need to have some kind of timing thing going on here. But I guess we can just pretty much... We probably just need to move this all to a thread, actually. So anyway, int ret. Funnel.h. Shut down CTX. Stream. Stream create. CTX. Hit. Default, what are we at here? Just say, 324. Oh, we need to set the dimensions also. Set dimensions, stream, set size, let's call this configure. Size, and we had, I think it was 512 by 512 on here. Yeah. Set rate. We don't really need set rate, but as well add it. Have it. think it doesn't really matter. Configure. Stream. And then we start the stream. Stop the stream. So then here we have the loop. And the loop will basically be dequeuing the stream. So in this case, we are going to use push. So we do a render and swap buffers and all that. And we're going to use the push timing in this case. So this will always succeed, but if buff is not, then we have no buffers left. So we just continue. And then how do I get this into... So draw triangle is called as... where is the texture? Draw scene. Oh, this is... Did I delete that somewhere? I think I moved the process call into here. On process, yeah. So this has to move somewhere else. So we draw the triangle locally at... This is going to be a little bit different to what we had before. So we draw the triangle onto the mainframe buffer. And then how do we... Is there a way of like copying frame buffer to texture? There's a GLBlit frame buffer, okay. Mm. Can I just use this without the FEO stuff? Yeah, OpenGL 3.0 has that. I'm asking for 3.3, so we should have that. Yeah, so I don't think we need the frame buffer ext stuff anymore. So in this case, we basically just do DQ, if not buff, no buffers, and continue. If we have a buffer, then we bind the texture, image target, get the image, assert width equals 0. And get the image, bind it to the texture. We generate a frame buffer. Yeah, I can just do this once anyway. Don't need to delete anything in this case, I guess. Yeah, I want to detach it, right? So then, and you apply this to the draw frame buffer. So we already did the render. Let's just put this at the bottom here. And then we swap buffers at the end. If no buffers, then okay, so we grab the image and assign it as a texture target, then set it as the draw frame buffer, assign the texture on there. Yeah, and GL frame buffer is GL draw frame buffer. And then I need the blit. GL blit frame buffer. Which version is this in? It's in all these. Okay, good. So we just need GL blit frame buffer. And filter doesn't matter. So we blit from the read frame buffer, which we have not modified, so should be the default frame buffer, to the draw frame buffer, and then detach it, delete the texture, and go back to drawing. So this is how you would use the library with a simple OpenGL app. Basically, if you're just drawing on the screen and sending what you have drawn, you would pull a buffer, get the EGL image, do this little dance to blit the data from the current frame buffer into the send buffer, and then should not need. Do we need GeoFlash? I'm not sure if we need GeoFlash. I think you need. Yeah, I think you need GeoFlash at least. Yeah, you need a GeoFlash to make sure that it actually goes into Pipewire. So after the GeoFlash, we would run stream NQ. Stream both. Return 0, and we just loop. And then final stream destroy. No, I do have that way. And then shut down. Okay. So if I'm lucky, this will be close to building at least the test app. Not quite. There's this. Oh yeah, we don't need any of this pipeline stuff. This should be a GLU int. GLU int. How do I get GL frame buffer draw? Oh, it's draw frame buffer, sorry. That is close to that. Stream destroy doesn't have a return argument. Yeah, I think that actually mostly compiled the yeah, I think they compiled the test app for the most part. Okay, so getting somewhere. Now for the interesting stuff in here. Okay, we need to get rid of all the NGS stuff in here. Yeah, okay. I'll take a very quick break, and then I'll be back, and let's just move all the logic into the funnel API and see if we can at least get this to somewhat work. I might actually want to also work on the OBS plugin after this, because if you remember the previous stream, I was doing some horrible permission stuff to get it to work. I'm just gonna fork the OBS portal stuff into a separate plugin and use that. So be right back. Uh, so I was gonna grab a quick snack, and I just realized that I can't find the snacks I thought I had. There's one here, but I think I need a bit more food. I hope it's okay if I grab something in the convenience store real quick, because otherwise I think I'm gonna kind of starve here. So, just give me like 5 minutes, okay? I'll be back really quick, and then we can move on to the library side of the code. Okay? Sorry about that. Be right back. I'm back. So, I'm going to eat something. Feel free to ask any questions or something while I'm having a snack because I'm really hungry and I can't work if I'm really hungry. So, let me know if you have any questions about what I'm working on. I used to mute myself when I eat, but I think people like it when I'm like, when you hear the the noises. I wonder how this bottle looks when I'm eating. Mm? Mm-hmm. 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 I've been away for a while. Are you okay? Yeah, I'm doing pretty good. Happy with work, everyday life, working on stuff. Cyan has been a little bit sick, and I also was sick earlier, so I've been working through that, but nothing horrible. So hopefully that will resolve pretty soon. And yeah, I wanna pick back up and go back to regular streams. Starting today. So hopefully there will be less of the long waits. So yeah, looking forward to the wedding. Thank you so much. Yeah, that's gonna be a big thing. Still about a year out because it'll probably be the end of next year. But yeah, it's really exciting. Mm-hmm. I'm not actually opening my mouth when I chew, but apparently the dragon picks it up like that. Mm-hmm. What is my favorite konbini? That's a difficult question. That tends to change depending on which one's closest to where I live. But I like things from all of them. Like, I really like the karaage-kun from Lawson, the Family Mart, like the buns with the chicken are really good, and 7-Eleven has lately they doing like chocolate chip cookies and things that are like made in the store like that, like warm, which is really awesome. So I don't know, I just kind of like go to whichever one I want, depending on what I feel like. So I think that's enough of a snack. So I'm not gonna like crash from low blood sugar. So hopefully it will be good. One thing I want to figure out is what am I gonna do with the main loop. So the way this is set up right now, I don't remember how I did it for the spout bridge, but I think I did something similar already. So let me see if I can figure it out. I don't know if it was this one or a different one. No, this is the old code. Where's the one I was working on? I think it was under Proton. Yeah, this is the one I was working on. I wanted to figure out... I don't know, but I was just copying to the texture, like, without any synchronization, right? I remember that now. How did I do it that time? Render.c. No. I forgot where I was doing this stuff. No, this isn't the code. I forgot where my code was. I was here then, I think. Must be? Is it? No. Where can I do this? Hold on a second. I forgot where my code was. Oh wait, I think I never got to this. I think what I was doing was... I think what I ended up doing was just... Was it? I was putting it out into a GL window. And then that was just getting captured into OBS, but I thought I... Did I ever get around to hooking up Spout2 to straight to OBS? Maybe I just never got there. I completely forgot. Maybe I just never got to that part of the code. That's possible. I just forgot what I did not do yet. Because I was capturing Spout2 into a GL window. Yeah, I think I just maybe never got there and I was just capturing the window. I think I just didn't get that far the last stream. Where's my phone? Where'd my phone go? Oh, lost my phone. 1 second. I think I just never got that. Let me check my post from last time. Because I just don't remember where I finished last stream. Ah, yeah, okay. I never got that far. I got as far as the pipe wire sender. And right, so I had Spout2. Yeah, I guess I never hooked it up. I had Spout2 sender to a Linux OpenGL window, and then I had direct Linux only what am I doing? Like Linux only sending into an OBS through Pipewire, but I never hooked them together, so I actually don't have the answer to the threading stuff. So I need to figure that out first before I mess up and do the wrong thing now. Because this all gets really complicated with like event loops and stuff like that. I want to keep this API simple so that at least in the common case you don't have to worry about event loops and things like that. And I think the way you do this is by like basically what I want is a setup where I can have a Pipewire thread and then run Pipewire operations from another thread. So how does this work? Why is there no documentation for this? Ah, there's a thread loop, okay. Ah, okay, this is what I want. I want a thread loop and then thread loop lock and thread loop unlock. Okay, that makes sense. Okay. Yeah, so that is what I want, a thread loop. Alright, alright. So, we go back to my internal. Close all that. Where's my internal file? Did I lose it? Include? As in, sorry. Okay. So, So instead of main loop, we have a thread loop. And then you run get loop, okay. So instead of main loop, we're gonna have a thread loop. And so then in funnel.c, we need to start implementing these functions. So let me grab funnel.h. Just gonna dump stuff at the bottom here. Create buffers. String configure, string start, string stop, destroy, queue, queue, return, get size. Okay. So funnel init has to, don't need any of this stuff. Basically do this stuff without the, okay, so PW init. I don't like this because this is assuming we I don't want to monopolize pipewire. How do I get the source code for this? Can I just call pipewire init multiple times? It says it can be called multiple times. Can it be called multiple times from multiple threads? I guess so, because this is calling pwinit like that. Yeah, okay, there's a global lock. That makes sense. Okay, yeah, so we just call it with null. Why is it 0? Yeah, that's weird. Okay. No. And that, yes, is void anyway. And then we want a deinit and funnel shutdown. There's just a safety there. important library stuff. We are not going to check for null pointers on memory allocations because that is... Nobody does that. This is not the kernel. I forgot. Yeah, just the other movement size. And mem size, okay. So the thread loop new name and props. No props for this one. Get loop on timeout data. Data? Wait, and data? STX loop. Let's put assertions in here. Okay, context loop, no zero, context new, and context. Is there a logging thing I can just kind of hijack? Might as well just use this, I guess. PW context connect. Disconnect from the core, destroy, and then thread loop destroy. So how do we use the thread loop? What's the right order? Okay, so you basically take the lock when you create the loop. Oh, you can do the simple stream stuff. Okay, that manages the core object. But we don't do that. We are going to manage the core ourselves. So that means that we start the loop here. So presumably this does the cleanup if the stream is a simple stream. Yeah, if it has a core, it removes the core and destroys the context. So the way the thread loop works, it does unlock, stop, and then clears out the context and then destroys the loop. Okay, that makes sense. So the order, and I need to make sure they get this right so we don't do things wrong here. So what we do is actually unlock, stop, and then like so we're supposed to be locked by the time we call here, right? We're supposed to be... Okay, no. Let me make sure I get the nesting right here. If I'm calling this for cleanup... So this should never be called if we don't have a loop. And then we destroy it after this. So the order is we if we have a core, we disconnect the core. If we have a context, we destroy the context. Then we destroy the thread loop. And just to be safe, we're gonna set the context to null until we actually have a context here. So if we actually this should be PCTX. For output, we'll call them P. P buff. Okay. So we have a bit of a we have some consistency here. P is used for output parameters. And I can just call it CTX, which is a bit easier. Video loop and timer. Did you come back to Asahi Dev anytime soon? No, sorry. Due to all the stuff that happened, I have no plans to go back to working on TPUs or kernel stuff. Let's try. So, do we need a? There's no documentation. Guess we probably just don't have to. Probably just don't need to do any of this. Something has to free it though. This destroyed source that has to be called. If the timer returns a source? Yeah, okay. Okay. So now in the error case, we have to unlock and then shut down. Okay. So then we have to listen to core events. And then main loop quit, but actually what we want is like a thread loop quit or something like that if there's a core error. But not really. Well, we don't necessarily want that because this is actually exiting the loop. We're not going to exit the loop. If it fails, we just... Hey, thank you so much for Super Chat! 好きなように生きていていいんだよりないつでも応援してます。ありがとうございました。ありがとうございます。スパチャありがとう。Okay. Thread loop. If we have a core error, I think we need some kind of all callbacks, all loop callbacks will be executed with the loop lock held. So this should be a loop callback, I think. So then the lock is held. Get loop. So if there's a core error, we mark it as dead. But we are not going to, is it allowed to call stop multiple times? It should, yeah, because it does a stop. And the way the locking worked, wait, no, is this supposed to be unlocked? Is this supposed to be unlocked? Yes, I'm not supposed to call stop from within the thread, I'm pretty sure. Yeah, so if it's dead, we just mark it as dead and failed all the calls. And we can still just lock and unlock around the loop. That should be fine. Yeah, okay, that makes sense. So what we want is, we add the listener, and then we just unlock it. And we return, which means it's just running. Where's the score at listener? Can that fail? I guess. Why is it like... Why is nothing documented, like the return values? I guess it's just not supposed to ever fail. Anyway. Hey everyone, thank you, Enter and QA. Welcome to Nina. Thank you so much for joining. Hey, JP, thank you so much for the super chat. And look at, thank you so much. Welcome to Team Nina. Thank you, everyone. Whew. Okay. So, final shutdown, loop, stop, disconnect, destroy. Okay. I think this should be fine as far as like cleanup. And I think that should never fail. Only the connection can fail, because otherwise it doesn't make any sense. Okay, so that's the initialization part. Then shutdown is done. We still have to deal with the streams, of course, but at least this stuff is kind of reasonable now. So core events, text data. Okay, cool. So stream create. I guess you don't know me love quit in this one. So this stuff should go in the EGL source. Let's just move things around before we get too complicated. Okay, so file stream. References the context. And final buffer is this BO thing we just got here. I think you can have up to 6 FDs or something with implicit sync, so let's just keep a bunch there. And let's also put array size in here since we're going to use that. Okay. So stream create. Where does this get created? That would be over here. Make node. Actually, no, that's just going to create a object, and we're not going to create the pipewire stream yet. Or we could create it and not. No, we don't want to create anything yet. Okay. So that's just gonna be a CLOC thing. Oh, and we can return the PCDX. Stream create. Insert that we have a context. So the stream should have a name. Oh, and the size of here should be star CTX. And this is pstream because it's an output. Stream equals null. Okay, that stream. CTX equals CTX. str.name. And then in the destroy function, assert stream. Actually, might as well play that one safe. Free the name. And then, since we're going to be setting properties on the stream, we need these things here. So width and height, set size. Set stream. Actually, I'm gonna have a sub function here. Stream config. Let's put this all into a substructure so we can then compare it and stuff. Let's config dot buffers. Right, def min max. Would be nice to have some sanity checks in here, but What did I use for undefined? Undefined is 0/1, so at least I think this is really the only check that's worth doing here. Okay, get rate. Don't have that yet. And then we need the stuff with the formats and the modifiers. So we need the GBM stuff in here because those are part of the core. So the GBM stuff. Let's go GBM. And that can fail, so GBM device destroy. And we're gonna do a config pending thing here so that if the config changes, we update. And then in stream, when it's created, we need to set the stream. Errors here. The rate we're not gonna require, they call it. The buffers, we can have some default. The size is required. So the buffers by default is to say 2, min 1, max 3 or something like that. Actually, min 2 because you always don't at least bounce one buffer around probably. Yeah, something like this. By default, it's pending. Okay, so now for the stream config is there's this make node is what we want. This is basically stream config. Okay. Properties, PW properties new. How do we disable client format? Like that. And is this going to actually... Is this gonna actually take ownership of the props? Yeah, it does free them. Okay. See, it would be so nice if things documented like what the ownership rules were. Name, data core. Okay, so now the format stuff. GPM enable format. Config dot formats equals realloc. And we're just gonna do the silly realloc thing here. Does Piper have any useful, like, list thing we can just use? It has an array. Okay, yeah, we can just use that. Yeah, I guess that doesn't really matter. PW rate in it should be fine. Formats. This needs to be modified as a pointer. I think I missed that somewhere. Ta-da. And we're always going to require modifiers because modifier-less setups are evil and we're not going to support them. I'm gonna call it add format. Instead of enable format. And I guess there should be there should be a reset formats or something like that. So when you wait, what's the difference between reset and clear? Okay, reset just resets the... Yeah, okay, we want reset. Okay. She's got clear formats. Okay. So get DBMBL is just going to be final buffer. Do you have that one? So then we also have to start doing the locking thing we're not doing yet, right? So thread loop lock and unlock. So basically all of these functions should be stream create for sure should be actually no, stream create doesn't necessarily need to lock the thread because it just creates a stream, but but this one certainly does. Unlock. Properties, and then stream new, CTX core, stream name, props, stream. Okay, so data stream is stream actually. So we have to refactor this parent stuff so it's actually dynamic. Let's see. Let's see. Let's make a little helper here for unlock veil. This got unlock return actually. So because this is reconfigured, we only want to create it if it does not exist. Otherwise, we just reconfigure. And the listener also gets it here. So now the format mess. No GL stuff here for sure. This process stuff just goes away. Keep the stream events. Keep the on commands. None of this attribute stuff. So, we're gonna build the formats. On timeout should be getting the... Okay, that is the That's the timer. So let's see, DX, stream, trigger, process. Okay, that's for each stream, but we actually need let's not do that right now. Build formats. Okay. I think this just gets config and doesn't need any. Okay, so this is returning the params, and the params is one for each format. So this pod builder, how do we make sure this is dynamic? Everything's using like static buffers. Yeah, everything's using static buffers. Okay, fine. Just pass it in here. Oh, that isn't even right. I don't know whether you fixed format there. Config width, config height. let's clean up these variables. Mix rate, def rate. Min rates. Mix rate. Yeah, that is wrong. That's supposed to be the format from the formats. Not sure how that happened. Okay. So the configure call probably should check that we have at least one format. There's the array stuff. Okay, so back to this document with all the crazy stuff. Okay, so the fixation stuff. Okay. So it's supposed to fixate on that enum format, but so enum format only modifying. Okay, so okay, I'm gonna go back to the KDE code for this. Because I remember I simplified this for silly reasons. So this works. This uses a fixed format, okay. It uses a fixed format, okay. I need another example for this. I need another example for this. What? Okay. Here's one example of how to do more than one format. Okay, push format object. Okay, yeah, this does multiple. So for each format, it is calling push format object. with a modifier list. And then what it's supposed to do is, on parent changed, it's supposed to push the one format with everything and fix it set to true, and then all the existing format params. Okay, so we basically have to repeat this for every format, and we are only doing DMA buff, no shared memory fallback for now, so okay. I think that kind of makes sense. Build format. And struct data is not used for anything here. Just take the builder, format, resolution, default frame rate, max frame rate, modifiers, no modifiers, modifiers flags. Okay, so the config here should use stream. So if fixate on params and params plus build format. No data on this one, builder, and then it would be stream core formats. Core modifier, one mandatory. And then we iterate over the formats list, which uses that array iteration thing. Yeah, that's the dynamic thing. Okay, that sounds nice. Okay, that makes a lot more sense. Dynamic builder in it. And it's not even documented, okay. Ah, but we can just have it return the pod from here. Okay. So we can use that one. Static struct, speed pod, build format. Pod builder. Yep, okay. So then we have all this. How does the frame rate work? I don't even know if this makes any sense. Who does this max frame rate stuff? Mother has it. Mother is using frame rate variable and then max frame rate default min max. Okay. Okay. And in this case, we actually just add one because this was the weird thing with the multiple formats. We don't do choice here anymore, so just builder add format. And then it's just format. Pass the first modifier twice. And then what this is doing with the dynamic builder and then this is just returning pop. So I guess this just the dynamic builder will just handle all that, so we don't have to worry about the size. Yeah, that should work. Okay, so build formats. And so we don't need a builder here anymore, which is what I want. No builder. Build format. Stream curve format, resolution different min rate max rate, modifier 1, mandatory, and for each config formats. And here we call the don't fixate. And return num-params. Okay. So now this should be doing roughly the right thing. Okay. So now we don't need a buffer anymore. We do need params. Params should be an array with at least as many formats as we need. So we get the number of formats, and then num formats, and then it's just +1. Okay, I think this makes sense. Okay, that should work. So, that's doing the stuff where it doesn't fixate, and then we need to basically do this with +1 for the fixate path, which is going to be in the in this part here, in param changed. No, wait, this is different. The build format is where? Ah, here, okay. If the dimensions change, it does the update params. Num params. True. And that just adds the one that is fixated. So we get the CTX, stream, CTX. Wait, GBM, that's not in CTX, it's in stream. Stream stream GBM dev. About Spout2. So Spout2 is a Windows-only technology used for sending video from one app to another. And what I'm doing is building something equivalent on Linux so that you can directly send video from your PNG tubing app into OBS without having to do screen capture. GPM dev. Okay, so we get this dev. Just to config here. Config. Width, config, heights. And I can just go in the core params like this here. Car format, car modifier. Height, width, plane counts. Test your DB above, okay. And that should be mostly what we want. SBA format. value counts. So what's going on here? We are going through the supported formats, and then modifiers is value count, value 0 is preferred choice, mod count. So we just deduplicate here, and okay, so parent changed. The listener here should be stream for the data. On commands, on parent changed, on state changed, on remove buffer, on add buffer. Getting somewhere. Build formats. Format. So then all the D stuff here on parent changed and data stream. We are parsing video format, which is there. Parse that from the format. Stream video format. Get the DMA by format out of that. So then if cur with height, and this is supposed to be using video format. So an action I'll configure with would be size width. Height. Amber's gonna double check that this is equal to the config, because if it's, well, actually no, if it is, yeah, the config should only be used for reconfiguring. So actually, we're not gonna use the config here for anything. The only tricky bit is that because it can be reconfigured, yeah, we don't need the config for anything here in principle. The only tricky bit is yeah, we just need to like have a separate one. So when we call configure, we should save a copy of the whole configuration so that we're not racing against everything else. So we lock, is there an array copy somewhere? Nah. Yeah, I can just add it, I guess. So on configure here, yeah, you do an update params, right? So we don't clear the formats. Oh, we clear cur, yes. And then actually just call reset. yeah, so we copy the formats over, and then actually, does it even make sense to copy them? I guess it just makes sense to, if on configure, we just always reset them, I guess. But I guess it's no guarantee that configure is actually going to reset them if it doesn't change. So, okay. Oh, and then for clearing it, we need to clear all these modifier lists, which is kind of annoying. Yes, we need a for each here, annoyingly. Set formats, and then clear. There's a for each thing. Yeah, for each macros. Yeah, there we go. Now that does the right thing. Okay. And then for copying the format, well, no, I guess, yeah, if no, okay, the modifiers, yeah. I guess I need a special thing for copying. Copy formats. And, oh, there's no memmed up? I thought memmed up was a thing. Oh, I guess it's not a thing. Yeah, it's not standard. Okay, fine. Okay, copy formats. And then build format should be using the current config formats. Oh, this memory management nonsense is scary, and this is why Rust is better than C. Hopefully I haven't gotten this wrong. Freeze the old formats, copies the config, then reinitializes the array, and then copies the formats. Okay. Okay, back to the build format. This is using the current config. Then on the parent changed rollback, we take video format, which should be in current video format at this point. So let's move that so it's less confusing. Okay, values, value count. Removes all the invalid ones. Test create DMA path. And then we don't need the buffer anymore. We just have that. Build formats, true params, certain params doesn't equal to non-formats plus 1. Update params, free params. Return. And then, otherwise it does this buffer stuff again. So here we need to go back to the config. Buffers. And then it's car plane count. And then I think I have a memory leak here. Probably no. Do I? I'm not sure. How does that work? I think you're supposed to free all those. Yeah, you're just supposed to free all those. No, it does build format params. Does this steal the... Oh, this probably steal... No, it shouldn't because there's a buffer. Not format params. Params... because this is probably using the automatic pointer stuff, okay. Yeah, it's auto cleanup. Okay, so that makes sense. But this is stealing the add object. Why are the docs so bad about all this? But there's an auto cleanup thing. Oh, so there's this auto PTR thing, auto on. SPA cleanup. Ah, okay, so it works like this. Okay, so this is the auto thing that is gonna free everything. But in this case, in build format, we don't want that because the color is going to have to free everything. So in this case, we wanted to auto clean up. Manual memory management is a pain. Okay, so this one is just returning top frame. Build format, build formats, returns all the formats, okay. Okay, so what this is doing now is it steals the pointer from the pod. think this is doing the right thing. Hopefully. Let's see if I don't completely bork my memory management. This is where I wish this would be Rust. Ah, okay. So how far am I from making this work? On add buffer does all this thing. dbm dev. Okay, that's wrong. We still have to do all the add buffer stuff. Enable timeouts. On state change, this is a callback on the stream, so this has to go on the stream. Enable timeouts. Stream. DX loop. Stream timer. Where's the timer? The timer. I feel like there should be a separate timer for each stream, not global. Yeah, the timer probably needs to go into the stream. On stream destroy. Stream timer. And I need to add the locking around this. Lock. Unlock. So we get CTX. And we need to destroy the stream. Stream destroy. And then buffer gets size, funnel buffer. We have the BO, so we can just return that from here. Width and height. And then GBM here, we're gonna have to do the... Oh no, just return the BO, and the BO has all the information we need. So, this is... The dimensions only matter for the UGL image. So then... what else? Final C. Hey Mario, hey Mary! Hopefully this will work. Hopefully this will work. Okay, where are we on command? Reverse process. Yeah, so also the timer this is fine now because this is now using the stream. So stream user data. Stream. And I should lock around the around that too. You probably don't need to assert those all the time. So the config should be the cur config. Is this even used here? I don't think it's used. No, this is not used. Okay. And count. Okay, and now just the buffer add and remove stuff. So, on remove buffer, we use funnel buffer here. So now the only other tricky thing is on remove buffer. If we are using the user's EGO display, we have a threading problem here. So how do we deal with that? Can I multi-thread EGO destroy image? I think I probably can. I think you can. I think you can destroy image from another thread. So this should be fine. GBM destroy. Okay, that's fine. So for Vulcan, we'll see what happens. How do I call this? Stream is it size? I need to do the stream API thing, which is stream init GBM. Init GBM, sorry, init EGL. EGL display. And then to add format. RGBA first. And then RGB, let's add both. Let's make the width and height configurable here. Okay, so back to phone. Let's see. In EGL, we have the okay, so first of all, in Funnel Internal, we need the buffer stuff. The EGL stuff is the attribute. This stuff here, EGL attributes. And then the EGL stuff is destroy image. And an alloc buffer. We throw in all this stuff. Stream, cur, playing can't. Plane count. FDs. Offsets. Strides. Modifier. Regional display. EGL image. Okay, that should be it for EGL. Ah! Okay, getting somewhere, getting somewhere. And then here on add buffer. But if I want to make these be separate shared libraries, then I need these callbacks to be separate. So I should be and then I guess the EGL display might as well be stored somewhere else. Just do that. And same in the buffer then, I guess. And then we don't need EGL or any of that stuff here. So alloc buffer, free buffer. Then we need init EGL. And I need some errors in here. Render node. Are you supposed to clean these up? I think you're not, okay. Where's open? I'm using F control dot H. And then we need to do the this stuff with the formats. Okay. So that should be enough for the open, and then we need to do the format mess. And I think we can just query this on the format set. Format set. And format. And then we should probably check here that this is one of the supported formats. So then the formats that are supported here that we are querying are pretty much just have to try all of them, I guess. okay. What is going on with the formatting here? So then for try format, and then modifiers. Count Modifiers, external count. Okay, check format, modifiers. And then the external stuff. I need to remove the ones that are external only, because it's painful stuff. This one. Count minus I. Minus 1. And then we clear those out. And we call the dbm add format. External return false. Something like that. Okay. And what's wrong with... Oh, yeah, this. Don't need that. Okay. Okay, I'm gonna take a very quick break. I'll be right back. I think we're getting there, though. And then fix an infinite number of compile errors, I'm sure. Why is this formatting so weird? I think I must have a bug somewhere. Oh, probably that. Ah, yes, that's why. Okay, there we go. And then in EGL, did we set the functions right? API CTX is display. And I need to import EGL in here. Hmm? Am I forgetting my C prototype format? Okay, where are we? How do I get the LSP to have the includes? Okay, there we go. I think this works now. Almost. Maybe not. Compatics? Wait. Show me a dictionary. How does this work? I think Mason can do this. Possibly. Hmm? Ah, it's in there, okay. Ah, I think that worked. Nice. Okay, so let's call that done. Buffer API buff. API buff. Why is Piper.h not found? Am I not configuring this right? Oh, I guess these need Pipewire too because they use the header file. Okay, better. And I guess we might as well use the GBM ones here. SPA 0.2. I think I probably need this. It's not there, okay. No. Huh? I just need. I'm missing the include here. Okay. So diagnostics, funnel fraction redefined. Why? We're missing stuff here. And then size of struct. Wait, no, on that buffer, yes, struct. Funnel buffer. Star. Funnel buffer? Where's my funnel buffer? account. Height, strides, offsets, strides. And then instead of this, we just do buffer. And I guess we can't really error out on that, so red loop and get loop. Build formats. Actually, just want to copy the declaration of this. And then we don't need any EGL in here. Render node. on. Declare identifier display. And buffer. Video format again. Where is this? This doesn't have the modifiers in there, okay. And then num formats is where is this? Okay. Stream, free params. And don't have the buffer anymore. Wait, what's going on here? Params? The constant. Discard qualifiers and nested pointer types. Const. No. Unprocessed. Where is this? Oh, we didn't have that. Unprocessed. Oh, this is the buffer thing. Yeah, we don't do that yet. That will eventually go on to Oh, we don't want to delete the stream there. Wait, no, yes, we do if it's a new stream. Oh, the compile errors! Okay, what's going on here? Format. Format. Mm-hmm. Stream, and then params. That again. What's this const thing? Getting there. So then what's the construct SPA pod thing here again? Am I supposed to just cast it or what's going on? Oh, it's because the pod is supposed to be constant already when built. Okay, so, that kind of makes sense. And then we just cheat on this one. I think it actually builds now. I'm just gonna delete that. Okay, and now, what about this thing? This probably needs to be one of those functions that gets pulled from somewhere. It isn't the BGL. Am I not linking with EGL? Ah, yes, we need those things. We need to get the functions are, yeah, these things. I guess I need to store some more context here. Can probably just make these globals. I think this will probably work. It's technically racy if you use it for multiple colors, but I don't think it's actually racy in any significant way. Okay. DSL missing from my final stream set buffers. Okay, and then just a couple more things here. Just need to get the EGL image. Read and Q and DQ are the only two things missing. And then in Q, just call that. Why does nothing document the return types? I guess we just return that. Oh, and then we need to get the buffer out. So we need a we need a recursive reference here. An internal grab and buffer. BW buffer. And I forgot to free the buffer there. And the return, I think it's called recycle or something like that. This is return buffer, okay. Oh, but we need to lock around these things, I think. This is RT safe though. I'm not sure if you actually have to lock those. Might not. You might not have to. I think you probably don't actually have to lock for these. Yeah, because this should be RT safe. So the only tricky thing here is what happens if the stream renegotiates in the middle of buffers being regenerated. Okay, so then the only remaining issue here is... Yeah, how do I update? How do the buffers get... So there's clear buffers, okay. So all the buffers go into the dequeued queue. Dequeued ones are okay. So queue buffer pops on the queue. Yeah, that returns it to the queued queue. So if I'm doing queued buffers. how does the renegotiation work when you... So on set param, it clears the buffers. I feel like I need some kind of DQ'd. Cute. So it has a list of all the buffers. Okay, I think I need to figure out where it's buffer flag added. Emits a remove buffer. So that means it actually is I think that means we actually need to lock things around the DQ and Q buffer. Which is kind of annoying. Because do I really want to block the entire thing while we are like copying to a buffer? I think I just have like a flag here or something. Yeah, I think I can just have a flag and have the buffers be deleted later. So basically, funnel buffer. If PWA buffer is null, then the buffer has been deleted. And so then I just need to lock that one thing. So if I could lock thread loop lock. So in DQ, I can DQ with a lock. And so if there's no buffer, unlock return 0. Otherwise, we grab the buffer and we say, it should be pbuff. Pbuff. So we need a flag here that is like DQ'd. So then we lock on enqueue, we lock, and we say buff dequeued equals false. But then if buff PW buffer, if we don't have a PW buffer, unlock return. What's a good error for this? E-stale, is that a thing? And the same story here. If we... Well, what just happened here? If we, and return, if it's stale, we just throw it away. It just checks for user data, so we can actually just do that. If we have user data, then buffer stream. And then, here's where we check the user data. Because all the callbacks are called with the blocks held. So if, not stream, sorry, buffer. If it's been dequeued, if it's not being dequeued, then free it immediately. And else we say buffer PW buffer equals no, which means we get rid of the PW buffer in this case. Yeah, that makes sense. Okay, so on remove buffer, if it's not been dequeued, we just free it immediately. Otherwise, we just set the PW buffer to null and defer it, and then Pipewire doesn't own this buffer anymore. And so then on DQ, relock, and then mark it as DQ'd. Make sure this is input on the certain here. Another assert here. And I guess this should be documented in here, so. Almost there. Final stream start, yes. Did we do anything for start in the original thing? Does it make node? I guess it doesn't really start. Maybe you just need that active thing. Ah, we can set a flag for that. Okay, cool. Let's do that. Oh, and we also need to do the get rate thing. And then for get rate, just need another locking thing here. Do I even have the right thing in here? State changed. Ah, it is. Frame rate is there, okay. Funnel. Current video format. And then I just need to check whether the format is actually configured. So ready gets called when we have buffers. What's the, I guess in progress? Probably. probably should have like an is ready or something like that. Or like a get state kind of deal. Well, we'll figure that out later, okay. That works! Suck fault! Stream set active. At least it found some formats and stuff. So we don't have a PW stream. I probably forgot to set something there. Okay, did I call configure on this one? I did not call configure, okay. But start should call configure implicitly. That makes sense. Okay. Where are we? Very stuck, it seems. We don't need all this stuff. Oh, what? Interesting. Sec fault. And then move. I guess I need Valgrind. This is the problem with C. But hopefully I don't have too many of these memory safety issues. It's not that complicated. There's only so much. I mean, the whole library is less than 1,000 lines of code. But yeah, it would be nice to use Rust, but probably more painful for other reasons. Why is it so slow? Wait, now it works? Also, what did I leak? Might as well check that. Stuff that's not my fault. So why is this exploding? Oh, that's definitely not right. Non-modifiers, is that uninitialized? Okay, no, that's not working. What's going on here? Something's not right here. Why am I getting very different modifier addresses? Like one is stack and one is heap or something? That looks like it's stack. Why are we copying modifiers from stack? That's not right. That's not right. that possible? No, something is really broken here. $520, B68. Okay, we have $598. Where did that come from? Oh, wait, hold on. Did I do that for retry? No, that should be right. Where's the bug? This is Intel. There's no Bungeroth. Formats. Reformats. Why is this broken? That's probably necessary, but not the problem. Okay, it's just that let's just add a bunch of prints. Come on, at least let me fix this. Yeah, okay, that is obviously wrong. 241 is right. Oh, this is wrong. What happened to the second one? How did we end up with the first one twice? That's not right. No, 24. Sorry, it's right. 5242. That's right. I mean, just not setting the count. Oh, I'm just dumb. I'm just dumb, but also, oh, because the array is not clear. Okay, yeah. Okay, yes. I'm just dumb. Okay, that's better. And now we're segfaulting in build format, which is another non-modifier's craziness, because I'm also not copying here. Stream select the column from wrong context. Ah. Oh, and unlock return is that. That. Huh? Okay. Now, how do I debug? Mesa. $268. Oh, because we're not even doing EGL. We're not even doing EGL anything here, right? In that format, inquiry. Okay, so something went wrong there. How? Oh, because some of these formats are not supported. Okay. Which is fine. I think I just don't need that. Okay. That works. Okay, so that's rendering. And now the question is, can I get it to show up in OBS with the horrible hack stuff I was doing before? OBS. Okay, here's some video. OBS input. Too much stuff. Okay, here's the Wayland. Input is 1. Port 376. The client. Is 74. I think that didn't quite work. Oh, it's probably the other one then. Or not? I forgot how to do this. Is it not connecting now, or is it just... I think it's not even trying to connect. Oh, it's 318, okay. No? Yeah, it's 74 in one of the others. Oh wait, I think this some stuff is broken here. These formats are wrong. That's why it doesn't get. It probably can't negotiate the formats. The format ID is wrong. The other stuff looks right. The format ID is wrong. I think I made that mistake before. That's a thing with the format. Build formats, build format. Yeah, I'm not using the right format type. And how did that ever work here? Probably because it was just wrong. Yeah, it was just hard coded. So I probably should just have the SPA format in here too. In file format. Just get SPA format in here, and then we already test for the format in here, so not quite. But it got something. It got on parent changed and then nothing. Because it got no format. That's still wrong. Because I didn't say it right. On parent change, it looks for the UMIPA format from SPA format, which would be stream core video format. sounds a sec faulted. Okay, getting somewhere. Okay, stream is dead and on add buffer. How did that happen? Probably because I didn't set buffer stream properly. Yeah. There we go. It works. That works. Okay. I really should call it. It's almost it's past 10 p.m. So yay! We're back at where we were on the last stream, except now this is a library that isn't a huge mess. So I didn't quite get to the Vulcan part this stream, but I got all the scaffolding working. So yeah, looks like it works. Also, why is this oh, this isn't RGBA. Why is this not RGBA? It's supposed to be it's supposed to have transparency. That's interesting. Did it like pick up a format that is not transparent? Or maybe my configuration is just wrong. Yeah, this is supposed to be RGBA. Probably just a problem with the test app not setting alpha properly. Oh, right, because we are copying from the X11 window, and the window itself is not going to have alpha by default. Yes. Because we didn't set it here. If I run it again now... Oh, no, bad surface. Did not like that. Choose config bad attribute. Oh, because then set EDL none. Aha, there we go. Now we have alpha. Now we have alpha. Oh, and apparently it's inverted. That's interesting. Coordinate transforms, how do they work? That's kind of interesting. I feel like this has to do with like the buffered dimensions, convention, something. think this is a thing with OpenGL in general. Be offered me shit. I was like, what? I mean, I guess this is really just if there's anything with the OpenGL coordinate space being different, I guess. Yeah, that's better. I'm not sure whose responsibility it is to do this, but I guess this is normally in OpenGL because the frame buffer is like bottom left. How is the screen set up here? Setup scene, GL setup scene. I didn't even do a yeah, I guess when you render it's flipped. Yeah, I think it's just a different API. probably use a thing for that. Oh, also, we probably want to make sure we set like the flags to pre-multiplied alpha. I'm not sure if we do that now, but oh, but like nobody uses that, I think. Yeah, that was the thing. Actually, I think I wrote that code. I'm pretty sure I wrote that code somewhere. Yeah, anyway, I'll figure this out later. Point is, it works. So, thank you everyone for coming. I need to get some dinner, because I'm really hungry, and get some sleep. So, thank you everyone. So hopefully next time we actually get to the Vulcan part. Now that GL is working again, and then we can plug it into Spout2. And also, I'm gonna write something for the OBS site, so I don't have to keep doing this horrible pipewire permissions hack. So thank you everyone for coming. If you have any questions or anything else, let me know. Otherwise, I'll see you next time. Let me get a bit of water. ET on the arm assembly. We need to look into that. Oh, the OBS permission thing is because of the portal stuff, which we're not going to use for the plugin I'm going to build. So I'm basically going to take the code that exists in OBS and just rip out all the portal stuff, and so then you can connect the sources a different way. Okay, thank you everyone for coming. I'll see you all next time. Bye bye. Bye bye.